So, welcome to all. Today we will discuss about the topic is Introduction to Aerospace Engineering in History of Flight. And in this chapter, earlier video lecture, we discussed about the basic history of aircraft and airplane and biplanes and monoplanes. But in this video, we will discuss about the development in aerodynamics. So before we go into that, what is meant by aircraft? So what is meant by aerodynamics? So aerodynamic means in every object which can fly is due to this air. So that is called as aerodynamics. For example, the rocket blasting and also the from basics of some kites also. And in object there will be occur in aerodynamics. There is some basics law behind that such as lift, drag, weight, and thrust also. This is a best example of an aerodynamics in outer surface of the object. So in this figure, it shows that the external aerodynamics of this aeroplane. It predicts between the forces and movements through the air to the relative wind. And it is an internal aerodynamics means it should be the inside of the main source of the aircraft. It's engine. Everyone we know that that is the engine. So in that engine, the aerodynamics how it will be affect. So from that air passes to the intake from the atmospheric air, and it goes to the compression part and combustion of the turbine, and also the exhaust part. Here will be the work done will be produced in the turbine. So this is an air circulation path in internal aerodynamics, and these are the some basic applications of aerodynamics in general aviation and vertical takeoff and landing and lighter than air vehicles and aerodynamic decelerators, road vehicles, spacecrafts, and also the propulsion systems. So here we mainly focus is spacecraft is the missiles, and the propulsion system is a propeller and jet turbines also. In airplane aerodynamics, it is the mainly focus on the components of the airplane is wing and fuselage and stabilizer surfaces, it including vertical and horizontal stabilizers. Everyone we know that this is a basic parts of an airplane. Here the wing, fuselage, and the tail surfaces will be the main occurring section of the aerodynamics affection parts. These are the forces of the aerodynamics, and there is a denotions. And here it will be these four forces how to implemented in the main airplane. It is a lift and weight section and thrust and drag section. And this is of the four forces which located and the axis of the aircraft. So in the tail wing, it will be having rotating about an yaw axis, and the main wing it will be in the lateral axis. It is an pitching concept, and the nose of the will be in a longitudinal axis. So in this axis, with respect to the airplane, with regarding the airplane will coincide with the outer surfaces of the aerodynamics. These are the moments that will be occurring in the particular airplane in the cruise section. With respect to the three axes, is the longitudinal, vertical, and lateral axis. With respect to the airplane center of gravity. The system and moments of an airplane with respect to the forces, and weight of the aircraft is opposite to the lift of the aircraft main laws. And a drag is force generated by the backward force of the aircraft, and thrust will be in the forward motion of the aircraft. It will be the main force, in particular that a force effect. It will be the object will be, or airplane will be moved into the forward direction, and this is an upward force. It's opposite to the downward force is an weight. So for example, if the four forces are balanced, the aircraft cruises at constant velocity and altitude. If the four forces are unfilled, the aircraft accelerates in the direction of the lateral axis. These are the simplified motion condition of the four forces with respect to the component wing and tail surfaces, and also in fuselage surfaces. These are the mechanics approach will be in the aerodynamic is in the fluid mechanic and mechanics approach. In the mechanic, it is a static and dynamic, and fluid it will be in the liquid and gas. These are the method of mechanic analysis. It is a static approach and also in a continuum mechanic approach. The statical approach will be is in the fluid molecules in how it be reacted in the particular object with respect to the fluid. And continuum mechanics approach, it will be the effect of the molecules how to be reacted in a particular object. Thank you.